Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. A few weeks ago, a new scientific study based on data from the Hubble Space Telescope was published, which affirms what many other papers have reported in recent years. And that is that the so-called expansion of the universe after the hypothetical Big Bang explosion appears to be accelerating much too quickly to explain through any kind of known physics. Now, of course, it was decades ago that scientists on Earth first noticed this kind of discordant data. Well, this problem led to the invention of a new type of energy called dark energy, which we are now told composes about 75% of the universe. Well, as we've reported previously many times on Space News, even taking into account the invention of dark energy's influence, the Hubble data has only deepened the problem. There is a discordancy between the apparent expansion rate of the so-called early universe and the later universe. Let me briefly read to you from a phys.org report on these findings. This discrepancy has been identified in scientific papers over the last several years, but it's been unclear whether the differences in measurement techniques are to blame, or whether the difference could result from unlucky measurements. The latest Hubble data lower the possibility that the discrepancy is only a fluke to 1 in 100,000. This is a significant gain from an earlier estimate less than a year ago of a chance of 1 in 3,000. These most precise Hubble measurements to date bolster the idea that new physics may be needed to explain the mismatch. Now, as members of the electric universe community have always known, plasma cosmology and the electric universe have always proposed that there was no Big Bang. The overriding issue in astrophysics is not just the raw data gleaned by telescopes and by spacecraft, but rather, how is that data interpreted? In fact, plasma cosmology and the electric universe have challenged the underpinnings of astrophysicists' methods of assessing the age and distance of celestial objects. Objects that appear very distant and very bright, and thus very huge, could actually be very close and very faint. And there is an abundant body of credible scientific evidence that this is indeed the case. So today we're going to discuss all of this and more with the Chief Science Advisor to the Thunderbolts Project, Wal Thornhill. Wal, why don't you begin by sharing what the official NASA report on this new Hubble data says and what your thoughts are?
A NASA report dated April 26th this year states, astronomers using NASA's Hubble Space Telescope say they have crossed an important threshold in revealing a discrepancy between the two key techniques for measuring the universe's expansion rate. The recent study strengthens the case that new theories may be needed to explain the forces that have shaped the cosmos. They go on to say scientists have run into an intriguing difference between what they predict and what they observe. But this has been a pattern throughout the space age. And the basic problem boils down to the origin of the Big Bang theory and the notion of an expanding universe. Our science is a cultural activity, and unfortunately, students are not taught the historical context to any degree, which gives them some idea where these original ideas came from. But fundamentally, the Big Bang theory is a direct outgrowth of the dominant cultural Western Judeo-Christian religion myths. And as a result, it had to have its own creation story. This is a feature of all cultures on Earth, that they have their individual creation stories. None of it has been understood until recently by some scholars who have not been recognized. But the fact is that the story that has been concocted is no more anything to do with science than the books relating the creation myths globally. In fact, it's only by understanding the origin of those global creation myths that you understand the universe, because they are trying to tell us something that we desperately need to understand.
Well, while it's interesting that one of the most common comments we receive in response to space news is from viewers stating that they can no longer stand to watch any mainstream documentaries or TV shows on cosmology because they're just too painfully aware that a more promising alternative exists with no acknowledgement from celebrity science personalities. When it comes to the Big Bang Theory, to me, it does seem incredible that we still see this posture, that it remains the best and most plausible story of the origins of the universe, despite its intractable problems, which only continue to grow with discovery. So if I were to ask a cosmologist why he or she still believes in the Big Bang Theory, in your opinion, what response would I be likely to get?
I find it difficult to watch science programs, particularly those based around cosmology these days, because so many so-called facts are presented which are not facts at all, but merely conjectures. The idea of the expanding universe was picked up by Einstein, who thought it was a very neat idea, it seems. And of course, it gave him room to produce his own theory of the expansion of the universe involving his gravitational theory. And that was picked up by Eddington. And Eddington, who was also a Quaker and had strong religious views associated with his science, was the one who championed Einstein's ideas. In fact, if it wasn't for Eddington, Einstein may have withered on the vine, because his papers, as they are presented now, would not have passed peer review these days. The expansion of the universe is based on Hubble's work. And of course, they say that he discovered the expansion of the universe through his measurements of redshift of distant galaxies. But that's not correct. His view was that the expansion idea was the least likely answer to this discovery of the redshift distance relationship, and that there would be some new physics involved. But no one ever tells you that, so we now have the Hubble telescope in honor of this so-called discovery, and I'm sure he'd be spinning in his grave if he heard the sorts of things that are attributed to his research these days. The very idea of the expansion of the universe makes no sense, because we understand space in 3 dimensions, and it is a concept of locations in 3 dimensions. There is nothing about space physical which can be expanded or contracted or twisted. It is merely a mathematical concept by adding extra dimensions. But what has to be made clear is that the dimensions that are used in mathematics have nothing necessarily to do with the 3 physical dimensions we both observe and exist in this universe. Those dimensions are merely degrees of freedom, and those degrees of freedom, the more they add, the more dimensions they add, the more freedom they have, the mathematicians, to invent whatever they like. Mm-hmm. And this is what's happened.
Well, as I alluded to in my opening, one of the things that physicists have invented in response to unexpected discovery is dark energy. But as I also alluded to, the whole idea of an expanding universe depends on the validity of the redshift equals distance assumption. We've talked many times about the importance of the late astronomer Halton Arp's research into that question. So why don't you explain the reasoning why an expanding universe is actually not necessary in light of science discovery?
The NASA report states, measurements of the galaxy's light reddens as it passes through a stretching universe. But of course, the idea of a stretching universe is non-physical and makes no physical sense. The reddening is used to calculate how fast the cosmos expands with time, a value known as the Hubble constant. But Halton Arp, the notable astronomer who was dubbed the modern-day Galileo because those who believed in the Big Bang refused to look at his data, said that he had discovered that the light from these highly redshifted objects occurs in discrete values, which means that there is something going on in the matter within the quasar and not with space. But of course, this is one reason why his work was not looked at. And Subramanian Chandrasekhar even scribbled across the top of his submitted paper, which was rejected, of course, This exceeds my imagination, and for that very reason should have been published. So then we read in the report, the Hubble tension between the early and late universe may be the most exciting development in cosmology in decades, said lead researcher and Nobel laureate Adam Rees of the Space Telescope Science Institute and Johns Hopkins University in Baltimore, Maryland. He goes on to say, this mismatch has been growing and has now reached a point that is really impossible to dismiss as a fluke. This disparity could not plausibly occur just by chance. In other words, this is saying just send more money and then we can invent more unobservable particles and mysterious energies. No one at any stage in any of this has suggested that we go back and have a look at the origins of the notion that Einstein's theory of gravity actually explains what we see in deep space, because the simple answer to that is it doesn't. Galaxies do not behave or rotate as if they're responding to gravity. What's more, Einstein's theory did away with the force of gravity. So you've got to ask the question, what is it that I feel when I hit the ground when I'm not supposed to be falling? There are so many problems with Einstein's view of the universe. It's amazing that people have actually taken it seriously. And I would suggest that more people have read about his theory of relativity and fewer people have understood anything at the end of it than any other book on any shelf. The reasons for this I can point out is that the idea that all of his observers are equivalent and have inertial frames of references that are equivalent cannot be so, because as Newton found with his bucket experiment, it seems that the water in his rotating bucket was aware of the matter in the rest of the universe. In other words, if the rest of the universe was rotating around that bucket and the bucket was stationary, the water would rise just as it was seen by Newton. And he understood that. But somewhere along the line, people have forgotten that. And in the days of classical physics, when real physics was being done, it was recognized that there had to be a connection between the matter on Earth and the matter in the rest of the universe, which is referred to as the fixed stars. But that's been lost. And as a result, we can no longer define mass, length, time, energy. None of these things are defined in any physically sensible manner. It requires that we set the context for physics. Otherwise, you stop doing physics. The report continues, in this new study, astronomers used Hubble to observe 70 pulsating stars called Cepheid variables in the Large Magellanic Cloud. A special class of pulsating star called the Cepheid variable, which brightens and dims at a predictable rate that corresponds to its intrinsic brightness. Once astronomers determine that value, they can measure the light from these stars to calculate an accurate distance to the galaxy. Now, this behavior of a Cepheid variable relies on an extremely complex model that has never been tested. It is far simpler to explain both the change in period and the brightness of a star by an electrical model of a star, which modulates both the apparent size and the brightness of a star's photosphere together. It should be pointed out that the standard gas model of stars has so many special conditions and assumptions built in that it could be tweaked to reproduce almost any observations. I should note that a Cepheid variable is a type of star that pulsates radially, varying in both diameter and temperature, and producing changes in brightness with a well-defined, stable period and amplitude. A strong direct relationship between a Cepheid variable's luminosity and pulsation period established them as important indicators of cosmic benchmarks for scaling galactic and extragalactic distances. As for the Large Magellanic Cloud, it's a member of our local group of galaxies. It's only 180,000 light years away, the second closest galaxy to us in the Milky Way. It has a low redshift interpreted as a velocity away from us of 278 kilometers per second. You put it in terms of the redshift, z, it's about 0.001, which is probably a true Doppler shift. But you cannot simply assume the high redshift of more distant galaxies is due entirely to the Doppler effect of velocity away from us. There is this assumption that the Cepheid variables will be operating under the same conditions in distant galaxies at high redshift. The electric universe suggests that the fact that these objects are highly redshifted shows that the energy contained within those objects, and therefore the masses of the protons and electrons in the atoms, will be different. They will be lighter, and the frequencies, the energy being emitted will be lower, which gives you, in effect, redshift. What's more, being an atomic phenomenon, it will be quantized. And yet this hasn't been recognized. It's quite remarkable. That means that you cannot use Cepheid variables simply as a distance measurement, because any redshift involved must also take into account possible quantized redshift, which is intrinsic and not Doppler shift. When Helton Up did that, he figured that the universe appeared to be static, which was a puzzle if you just assumed that the universe was operating gravitationally, because the whole thing should collapse inwards. But he found that this meant that gravity must also be a balanced force. It can repel as well as attract. And this was the puzzle that the electric universe set out to solve some time ago.